in one language versus another? Well, we live in a world of polyglot languages, isn't it? Which means we can use multiple different languages to run our code on the JVM. Well, rather than having to be forced to use one language, we could use multiple different languages. In a way, if you really think about it, what if languages are like vehicles? You could use a bicycle, you could use a car, you could use a train, and in general, on a given day, we typically use multiple different vehicles to move around, isn't it? You may start your morning, you may go from your home to the train station in a bicycle, you may take the train, and then when you get off, you may take a little auto to go to where you want to go, and we kind of mix vehicles. Why do we do this? Because it's convenient to use different vehicles for different purposes. And in a similar way, what if languages are looked upon like as vehicles? We can mix and match them. And it turns out that Java, JVM, has some really nice popular languages, and we can make use of certain things. So let's talk about a few things we can actually do. I want to access a file. How do I access a file? I want to read a file, let's say. How do I read a file's content? Well, in Java, of course, you can read files' content, but that can become verbose, it can become ceremonious. But maybe you can do this in other languages, where it can save you quite a bit of time and effort. So for example, let's take a look at an example in Groovy, if you will. And what I could do here is I could say define file is equal to new file. And maybe I'm interested in the file etc, let's say, host, or how about reading the same file here, sample.groovy, right? That same exact file we have right now, I'm going to go ahead and read that file. So new file is just reading that file that we have with us. But how do we get the content of that file that we have? What if I said text to get the text out of that file? And what if I now say, we'll call this as content, and then once I get the content out of the file, maybe we can simply print out the content of the file itself. That is the code that's reading the content of the file, as you can see. Again, as you can see, it's very easy to write code like this, low ceremony. You don't have to write a noisy piece of code. Life becomes really easy. Well, this is one of the things to really think about when it comes to languages. Maybe it's a little bit more effort to do in one language, but it's so much easier in another. And all of a sudden you say, well, I can write this code in this language, and I can write that code in other language, compile it down to bytecode and run it. Just like how you would take a bicycle to the train station and take a train from there. You can mix and match them to get your work done. So that becomes an example of how you can easily read a content of a file without much effort. Now you may look at me and say, well, Venkat, you know one thing though, you can do this in Java. Like how? Well, in the old days of Java, what did you do? You said buffered input stream, buffer input stream equal to new buffered input stream, parenthesis, new file input stream, and then you take a breath, right? And then what does Java say? How do you read the content? You say while string is not equal to null, remember that? How do you feel about it? And when you're done with it, what does Java say? Java says, what about exceptions? And you put try and catch block around it. And then when you look at it, it looks like this code went through some accident, isn't it? And you're like, gosh, what is all this? Try and catch and all that. That is ceremony. Whereas here, you're able to write the code much easily. But what if things were to fail? What if things were to go wrong? Well, sure, you can come and add try and catch around it also here, but you don't have to do it in the beginning. You can incrementally add code towards that, and that becomes a lot easier to work with. So that is basically the idea. You can read it in a very similar way. Likewise, in the case of Scala, you can go to source and you can read it from the source as well in a very similar way. So you can read it almost with 1 or 2 lines of code, not a big deal. But what about interacting with external processes? Well, I'll share with you a story about it. Years ago, I had an application where I wanted to receive requests when typically like in a version control, for example, or I have a backend system and a request comes in, and when a request comes in, based on the request, I want to start a process. And if I'm going to start a process, and once I run the process, I will send input to the process, I'll take the output of the process, and I have to parse it. And I decided to write this code in Java. And when I wrote this code in Java, to be fair, it was not a lot of code. But the entire code was, give or take about 200 lines of code. But then I looked at this code, and in about 200 lines of code, just to start this process and send the input, get the output, that code was about 75 lines of code. Now look at the signal to noise ratio, isn't it? For what you want to do is about 200 lines, and out of which 75 to 80 lines is just to talk to this process. And it worked, but programmers will secretly tell you something. It's more fun to rewrite code than to reuse code, right? Because if you rewrite the code, you can waste an entire day doing it. If you reuse it, it'll get done in a few minutes. What fun is that? So a few years went by, and I looked at the system and I said, hey, I have an opportunity to rewrite this part. And I rewrote that code in Groovy. And when I rewrote that code in Groovy, that 75 lines of code turned out to be 3 lines of code. Because in Groovy, you don't have to do that much work to do simple things. Like, for example, let's say I want to talk to, Git. So how do I talk to Git? Let me bring up a terminal to take a look at it. So I want to talk to Git. And what do I want to call on the Git? I'm saying Git, let's say Git help. That's all I'm going to do. And it printed the help. But I want to do this from within my program. Obviously, you're not going to run Git help from your program, but maybe you want to do a commit or start a process. How do you do that? Well, here's an idea. This is Groovy code. I'm going to create a string. And what is my string? My string is Git help. And I'm going to just print it. Now, obviously, it's going to print Git help. But then, you can take a string like this, and you can then on that string say execute. And when you call execute on a string, what does that tell you? Suddenly you notice it's a Java Lang Unix process. Now what did Groovy do? Groovy says if you give me a string, Groovy will add methods to a string. And the method it added is actually the execute method. Make no mistake, it's still Java Lang string. But Groovy takes existing classes and adds methods to it. And they added a method called the execute method. Then on the execute method, I call a text over here. And look at that. That's the output from Git right there. And that is how trivial it is to take a command you want to run on the shell, execute the command, and get the standard output of the command. Or similarly, standard error, and so on. So when you start doing something like this, you're not wasting your effort trying to really write a lot of code. The language kind of bends over its back to make things easier for you. And then that's got a big benefit because we don't have to endure the effort. We can get our work done very quickly. So one of the things to really think about is, why do people get excited about languages like Python? One of the reasons is these languages are phenomenally good for prototyping. What is programming? I'll tell you what programming is for me. Programming for me is a series of light bulb moments. You're sitting and working, oh look, here's what I can do. Really? Let's try it out. And you're like, oh wow, that's awesome. It almost does what I want to do. Hey, try this one. And within about 15 minutes, you got something working, isn't it? But when you're working with a language which is high ceremony, what happens? You say, oh, I got an idea. Like what? Let me try this out. And the compiler is like, what about try catch exception? You're like, you know what? Never mind. I'll try this some other day. Let's go for lunch. That's how you feel about it, right? You don't want the language to impede you. You want the language to work with you. And you want to just be on the flow. And sometimes that happens to you, right? You are pairing with somebody, and they say something, you say something, and you guys are high-fiving each other. How does that feel? And you're like, gosh, we cranked out some code today, right? And while you both are having this harmonious moment, the compiler in the middle says, remember me? And you're like, never mind, this is not for us today. Well, these things can help you keep that flow between you, and you can try ideas really quickly because you're able to crank out some ideas and try things out. And that becomes really a powerful way to use things. The next thing I want to talk about, to be fair, is in Java 8. This is one of my favorite design patterns. It's called the execute around method pattern. When Java introduced lambdas, I was very curious. Java has lambdas, but Java's lambdas are new, which means Java programmers have not really put this to use. But lambdas are not news. Lambdas are not new. So out of no good reason, I went back in time and started reading old books that used lambdas, because I want to know what did my predecessors did with lambdas that we can learn and apply in Java. And I found this book, which I think is a terribly named book, but it's a beautiful book. It's called Smalltalk Best Practices by Ken Beck. And I said, hey, Smalltalk has had lambdas for a while. I wonder what they did in Smalltalk. Maybe we can do some of those in Java. And I discovered a pattern in his book, and that pattern is called execute around method pattern. And when I read that pattern, my mind was blown, because that gives a way for us to use lambdas to perform a certain type of operations. And then I noticed that kind of work is being done in languages like Ruby and Python and a lot of other languages, because those languages have had lambdas. And then I realized I can do this in Java also. So let's understand this with a little example to see what that really means. But before we talk about that example, let me talk about one project I was working on. Let's say we have a class called resource, and the resource contains a constructor, and I'm going to say output, we'll simply say in this case created. And then I have a public, let's say resource, we'll call it op1, and all I'm going to do is output, let's say op1, and then return this. I'm going to write one more method right in here, we'll call this op2, and all that it does is prints op2 and returns 2. But imagine for a minute that this resource is an object that contains some really external resources. Maybe it's got a connection to a database. Maybe it's got a reference to a file system, maybe open socket, maybe a connection to a microservice, whatever it is, right? It's an external resource. Well, how do you release that external resource? Well, you know that in Java, it has automatic garbage collection. Unfortunately, though, as much as Java has automatic garbage collection, you don't know when the garbage collector will be called. So if you were to write a finalized method, and in the finalized method you say clean up, let's say clean up external resource. Now, what's going to happen in this example? When I say resource equal to new resource, resource.op1 and resource.op2, and I've called these two resources, but you know that I need to clean up the external resource. If this was a file or a database connection, I need to close it. Now, just before I run this code, a little word of caution. I'm using Java 11 on this particular example. In Java 9, they did something really beautiful. They deprecated finalize in Java 9, because that is the right thing to do. Why? The reason they deprecated it is, when you run this code, you will notice why they deprecated. Notice it says warning deprecation. Ignore that warning for a minute for me. What is important is, look in the bottom of the output. What did you see? You did not see one thing. What is that? Did not clean up the resource. In other words, it did not call the finalize at all. If this was Java 8, what's the code going to do at this point? Let's see if I can do this in Java 8 for you. So I'm going to go to work area Java where I have this code, and I'm going to say set Java 8, and I'm going to then run this in Java 8. Set Java 8 maybe? So I'm going to say over here, compile and run this code. I'm going to just run this code and see what it tells me. And then when I run this code, what is the output it tells me? I'm just doing this on the command line just to get the feel for this. So let's go ahead and run this code. And notice it did not give a warning, but it did not clean up the object, isn't it? Now, why did it not clean up the object? The reason it did not clean up the object is the garbage collector. How does the garbage collector work in Java? Well, the garbage collector in Java is like the garbage collector in my neighborhood. Just because I put the trash out doesn't mean they come and get it. They say, oh, Venkat put the trash, who cares? Let it be there for a while, right? So in this case, Java looks at this and says, hey, there's a lot of memory. I don't need to run the garbage collector. You know how some programmers are? They were like, but I want it to run. And what would they do? This is something they will do. They will go to this code and say system.gc. You know what this is called? Hope. Right? That's what it is called. It's called hope. That's a beautiful thing, isn't it? It's hope. Now what happens when you run this? And you go ahead and run this code now, and what does Java say? Really? Whoever wrote that method is a genius. Because he said, for generations, I'll screw with the programmers. I bet you open the source code, it's a no-op, right? They just put it in and say, let's see who does this. They're just playing games with us. Well, clearly that ignores it, right? So what's the problem? I'll tell you a story. I would never forget this. A company called me and they said, hey, Venkat, can you come and help us do code review and help us improve the code? I said, I can do that. I love doing it. And then the boss said, oh, by the way, while you're at it, do us a favor. We have a bug. Help us fix it. And I asked the boss, can you tell me what the bug is? And the boss said, go ask the programmers. I said, okay. I went to ask programmers, and nobody would tell me what the bug is. It's kind of hard, isn't it? To fix a bug, you don't even know what the bug is. And then finally I find one programmer, and he nailed it. He said, the code works fine most of the time. I said, that's awesome. I said, could you please enlighten me? Are there times when it doesn't work? He said, oh, of course. It doesn't work between 7:15 and 9 in the morning. I said, oh my goodness, every day? He said, no, only Monday through Friday. I'm like, okay, I'm doomed. Right? What is special about Monday through Friday? I said, you know what? You've been very helpful, thank you. I said, I'll forget it. Then I started doing code review, and I found out what the problem was. What these guys had done is they had one object. Oh, by the way, this program was running in a portal. And I was reading the code, and they had a class. In the constructor, they go get a database connection. And I'm like, this is interesting. They got a connection in the database, and my eyes are scanning down, and guess what? Finalize method. And what do they do in the finalize? Closing the connection. And I'm like, interesting. You know what the word interesting means, right? It's a polite way of saying stupid, right? I'm like, this is interesting. And I'm like, gosh, that means you get the connection, but you have a lot of memory, and the runtime says, there's a lot of memory, never bother collecting the garbage. And the finalize is not called. And when you keep acquiring all these connections, what happens? It is blowing up in the constructor. And what happens when you blow in the constructor? They're not handling the exception properly, right? And I'm thinking, maybe this is what is happening here. And then, this is the funny part is, as I was talking about this, in the corner of the room, there's one guy who never spoke. I always get nervous when there's one person who never speaks. But this guy was a little different. He never spoke, but he was eating pizza. And I'm talking to this developer, hey, I've got a hunch. You said this is a problem, I got a hunch. Maybe this is a problem with finalize method. So I told him, let's give it a try. And what I did is I went to this code and I said, let's try something. And I changed this finalize to close. That's what I did. And then I came in here and I said resource.close, and I called that method called close. When you run the code, of course, it calls the close method. And I said, if we do this, it should release the connection. I think that's what your problem is. And we both are talking about it, and suddenly this guy who never spoke, he said, yeah, that's the problem. I'm like, who are you? And you never spoke until now. He's like, oh, I saw what you guys are doing, and I've been monitoring the database connections on the server. And when you modified this and put that into the server, I noticed the connection is flat. Until now it's been increasing. I'm like, I like you, continue eating pizza and listen to us, right? And he was actually for good use. But you know this code is not the right solution. You know what the problem is with this code, right? Yeah, exception. I heard the whisper. You said exception. But the fun part was, I put this close method, and then the team was like excited because they've been having this problem for a long time. And when the boss came back from lunch, they had to rush to the boss and say, boss, we got a great news for you. And the boss is like, what? We fixed the problem. And the boss is like, that's awesome. What did you guys do? And they said, oh, Venkat asked us to add that one line of code, and we added it, and the problem is gone. And the boss is like, what else did he do? No, that's it. He added this one line, and the problem is gone. and there's a silence in the room, and I can overhear him asking, if you only wrote one line of code, do we need to still pay him? So, well, clearly, this is not enough, isn't it? So what do? You have to put the try block around it. So you put try, and then you put these two pieces of code within the try block. Then what do you do here? Finally, isn't it? You put it in finally. Why? Because even if there was an exception, you want that code to be called. Good news, that code will do the work. Bad news, it's verbose, isn't it? Three problems, right? What are the three problems? You may forget to call close. Even if you remember to call close, you could be doing it wrong. And if you do it right, the code is verbose. So what do? How do you deal with this? Well, first let's talk about making the code concise. How do you make the code concise? To make the code concise, you can use a beautiful feature in Java 7. It is called ARM, which stands for Automatic Resource Management. And what does ARM say? ARM says, if you want to clean up the resource properly, go to this class and say implements auto-closable, right? So implement auto-closable. Well, what does auto-closable expect you to do? To have a method called close. Ta-da, we already have that. Then what do? You then go here and say resource, you grab that resource, and you put it right in the parenthesis, right in there. Good news, you don't have to do this now. What's the benefit? You run the code, notice how close was called automatically. That's nice, isn't it? So what is the benefit of the ARM feature? Less code to write, more concise, isn't it? That's nice. Oh, but wait a minute. That's nice, agreed. But what if I forget to call try? What if I do this? What's going to happen? What do you think? The compiler will give me an error. Would you agree? No. All right. The compiler knows that I'm using auto-closable, isn't it? So the compiler will give me a warning. Is it true? No. What does it do? Nothing. But you know this already, right? Because deep down in your heart, you already know this. Never ever to trust a feature with the word management in its name. So, doesn't work. So clearly, right, it doesn't do anything. And what do? They then blame us, like management. If you guys know what you're doing, right? And I'm not a fan of such approach. I don't want to be blamed like that. So this is why I'm not a big fan of this approach. I'm going to get rid of it. So what gives? What do I do then if I'm not going to use it? So back to square one, isn't it? No garbage, not being collected properly. Enters ARM. So what am I going to do with ARM? I'm going to first of all go to the close method and make the close method private. And when I make the close method private, what happens? The programmer is like, I don't care, because I'm not calling it anyways. It's like, okay, fair enough. Then I go to the constructor, and I make the constructor private. When I make the constructor private, what happens? Well, you cannot create an object anymore. What gives? Notice line 22 failed. And the programmer is like, I don't understand this. How do I create a resource if I cannot access the constructor? Now we're going to provide a way to do this in a very clear way. So what am I going to do? I go to the class, and I write a public static over here. And what is the name of this method? Use. That's the name of my method. I call it as a use method. Now within the use method, I'm going to say resource equal to new resource. Then I put a try and I put a finally. You say, wait a minute, what if you forget to do it? You know what? I'm the one who's writing the class. I wouldn't forget it. I'm writing the use method for a good reason. I'm not going to have that much of a memory lapse, right? This is how you're designing your class. It's quite possible that users of your class can forget it, but you're the author of the class, you wouldn't forget to write that. So what are you going to do here? You say resource.close and you close it. But within here, you say block.accept resource. What does that even mean? Block.accept. We don't have a block. Sure we do. We can bring that in. So I'm going to say java.util.function.star, and then I come to the use method and I say consumer of resource block. So now what I did is the use method says, give me a block of code, a lambda, and I'm going to create a resource, pass the resource to the lambda, to the block of code. Whether it comes back alive or dead, I'll close the connection. Now notice how this deterministically structures it. How does this help us? Then I go to the code right here and say resource.use. And then what? Resource arrow. And then within here, I'm going to say resource.op1.op2, and I can call these methods within that. And when I execute the code like this, it cleans up automatically for you. And guess what you cannot say? You cannot say, I forgot. There is nothing to forget, right? And this is deterministic. This approach is a way for us to execute a piece of code, but around the code to do a pre-op and a post-op. Different languages have different names for this idea. In languages like Groovy and Ruby, you open a file, but you never close it. Why? Because when you leave the open function, it automatically closes it for you. How convenient, you don't have to forget it. In the case of, this is called execute around method pattern, because here is the code, but you do something around it before and after. In the case of Scala, they call this as a loan pattern. Why do they call it loan pattern? It's as if the object is on loan to you, like you go get a rental car. And what happens when you get a rental car? Assuming it's a good company, they clean up the car and give it to you. And what happens when you return a car? They check for damages, more for me than others. But the point is that there's a pre-op and a post-op, but then in the middle you can drive it around. So this is called a loan pattern and gives you that flexibility. So what we did here is we used lambdas to attain that kind of flexibility. This brings us to the next thing I want to talk about, which are traits. Traits are really awesome feature in Scala. So what is a trait? A trait is like, if you will, a trait is literally like an interface. Well, if trait is just an interface, why can't you just be happy with interfaces? Well, in the case of Scala, the traits can have implementation of methods. If you're in Java 6 and Java 7, you say, whoa, that's awesome. And then you say, wait a minute, in Java 8, we have default methods. So what's the big deal? Aha, that's a really good question. Are traits still relevant if you can have default methods in interfaces in Java? And the answer is yes, because Java interfaces lacks one concept still. The beauty of traits is not the fact that they can have methods, implementations. The beauty of traits is they are stackable. So what is stackability? Stackability is where a trait can form a chain and you can pass the calls from one trait to another, to another, to another, and you can move through it, and that becomes a really powerful way to deal with it. So let's look at an example of this, how we could use it. Suppose I have a little function here. Let's say in this case, I'm going to create a class. We'll create an abstract class. And this class I'm going to create over here. Well, actually, you know what? Let's define a function. Define a function called listen. And what does this listen function do? It takes, let's say, a man object. And I'm going to simply call this man and say man dot, let's say, listen. So this man is going to listen. Let's call this as seek help. So what does seek help mean? You're going to take a man and say, listen. You're going to go to the man and say, hey, can you please listen to me? And of course, in this case, I can create a class called man. And what does a man contain? A man contains a function called listen, right? And this can simply say, all right, I'm going to listen, and maybe the implementation simply says listening or something like this. So if you were to write code like this, what it's going to do? Well, you can obviously take a man and pass it to the listen function. So you can say seek help, and you can create an object. You can say new man, and you can pass that object to this function to call the listen function and have it executed. Now, obviously, in this case, it says listening. You could even put a name for this particular object. You can say val name is a string, and you could say this is a man whose name is Peter. And then you can say listening, and who is listening? You can say Peter is listening. So dollar name, is listening, right? So you can write code like this. But if you write code like this, what happens? The listen method is part of a man class. What if you have a women class? Well, if the women class contains a listen method, Well, obviously, that's going to be a duplication of code because that's going to be listen in both. And eventually you realize, maybe I'm not going to have those classes, I'll have a human class over here. And of course, a human can listen. So in this case, you can say this is human, so I can do this for both men and women, so that becomes a human as well. That becomes a lot more extensible. But if you do this, then what happens? Let's talk about the listen method. Who listens anyways? Yeah, that's the problem. Most people don't, right? But who really listens? I would say the one who listens is a friend, isn't it? Isn't that what friends are for? Right? You had a very tiring day at work. You meet your friend and you say, you know what? Today was really bad. I hate this job. What does your friend say? Tell me about it. And listens to you. What does a bad person say? Not a friend. Says maybe you suck, not your boss, not your company, right? That's how you know who your friends are. So in this case, a good friend listens. But let's not forget about one very important friend who always listens to you and never talks back at you. Who's that? Man's best friend. Dogs, right? Dog. I was asking this question, one guy said, my wife. I looked at him and said, how long have you been married? He said, last week. I said, I'm sorry, that changes very quickly, right? So anyways, dog, right? Man's best friend. So in this case, what an illusion we live by. Okay, anyways, so if I were to create a class called dog, what's going to happen? Well, the class dog is going to have a name, of course, a string. And I'm going to have a listen method in that. That's going to be duplication of code, isn't it? Let's give it a try. Trait. Trait called friend. What does the trait friend have? It contains a val name, which is a string, but that's not implemented. Then I say define listen. Just grab it from here. So you can see that the trait comes in here as a listen name. But then what I can do is I can go to the human, remove this code, I can say extends friend. So a human becomes a friend. What is the benefit of this? The benefit of this is I can say class dog and dog val name, of course, because dog has a name, string, and it extends from friend as well. So as a result, it becomes a lot easier. So what can I do over here? I can say over here, seek help, new dog. And I can say, this dog is rover dog, and I can call this function, and what does it do? I can pass an object of a dog to this, and what does that become? It becomes a friend, isn't it? So friend, and I'm going to say friend.listen. So the code becomes extensible as time goes on. But of course, you can say in here, dog extends animal, and then you can say animal with friend if you had an animal class. So this gives you an ability to stack up on these things. But I haven't shown you the stacking here though. And what does the stacking really mean? Stacking really means you can add more things to this. Like what? For example, let's say we have a class called animal, right? What does a class animal do? Animal has a name string. Great so far. But value name is going to be override. Override, and I'm going to say name extends animal, and that's going to take the name as a parameter and pass it up. Then what am I going to do? Then I'm going to create a class called cat. And what does a cat contain? Override val name, which is a string, which extends from animal. So far so good, isn't it? Then what am I going to do? I'm going to say over here, a value alf equal to new cat alf. Then I say seek help alf. Will that work? No. Why not? Very simple. Because cats are not friends. Right? Anybody with a cat here? Nobody with a cat? Come on, this is serious business. You do have a cat. Is cat friendly to you? Yes? He's an illusion. Clearly, right? He's absolutely an illusion. Because when you go home, what does a dog do? It jumps all over you. It's so happy you're home, right? What does a cat do? Cat says, why are you here? Leave some more food and go away. That's what cats do, right? Cats are not friends. You still think it's a friend? What's your name, sir? A little louder. Vishwanath. How do I tell this to you, Vishwanath? Do you have a name for your cat? Lakshmi. What is that called? Lakshmi. This is getting really weird. Vishwanath, I'm not promising you anything. So, is that Lakshmi you're talking about? That's the Lakshmi with spelling is correct? You had a different spelling for your Lakshmi? Let's keep this for now. Equal to new cat, Lakshmi. Okay. Seek help from Lakshmi. There we go. We tried. It doesn't work. Sorry. But I know what Vishwanath is saying. Vishwanath is saying, but I know it's friendly. It even feels like it's wagging its tail when I look at it, right? Okay, I'm not promising still, but we'll try. With friend. What's going to happen here? Well, of course, in this case, I have a new cat I'm defining, but I'm going to take this cat, but I'm going to put a friend on it. Let's see what it's saying here, extends friend. Of course, I was wrong here in the cat, isn't it? Got to pass that name over here. But nevertheless, come back here. And when I go back here, we'll come back to Lakshmi in a second. But if we go back here and run this, Alf is no use, right? You cannot pass an Alf. Alf is not a friend. Alf looks at you and says, why are you here? But Lakshmi is special. So let's go ahead and try this again. Beautiful. Are you happy now? Look at him, right? Look at him. He's the happiest person. I want to follow you home and see how you are tonight, right? He's going to like, you're my best friend ever, right? This is amazing. Awesome. Well, that's an example of traits and how you can mix traits really nicely into Scala. Very powerful idea, isn't it? Joining strings. You can join strings together very easily by using the function called join. So for example, if I were to have, let's say a list of strings, let's say, in this case, names is equal to a list of. And I'm going to take some names over here. So what do I want to do with these names given to me? Well, I want to combine them all, comma separated. So I can say out here, names.stream dot, I could say collect. And collect what? Joining. And I can join them with a comma or anything else I want to join them with. And that becomes a nice way to use the joining method, which comes from collectors, by the way. So when I go back and run this code, what it's going to do, it is going to join all of them, comma separated. And that becomes a very easy way to concatenate objects. You could perform other operations like mapping. So you can say map, and you can say given a string, convert it to uppercase, to uppercase like this, and you can get a beautiful conversion and joining with strings as well. Very powerful set of operations. So this is a lot easier to work with. It removes a lot of ceremony, ugliness in the code. Laziness. Let's talk about laziness. I'm going to show it to you here in Scala, but you can do that very similarly in Kotlin as well. So let's say for a minute, I have a function called compute. The compute function takes an int over here. And what does this do? This function says print called, and then it simply returns n times 2. Nothing really exciting. Then I say val x equal to 4. If x is greater than 5 and compute of x is greater than 7, I'm going to say print line path 1. Else, what am I going to do? Print line path 2. Question for you. Will the compute method be called now? What do you think? Will it call compute? No. Why will it not call compute? 2 words or 1 word, depending on how you say it. That's right, short circuiting. Short circuiting. Yeah, everybody knows short circuiting, isn't it? Who did that? The very first language to introduce short circuiting was Lisp. John McCarthy introduced it. But you know what? Everybody knows short circuiting, isn't it? Moms, when they feed their children, they teach them. They spoon feed and say, kid, when you grow up, be aware of short circuiting. Functions may not get called. So children know this. They grow knowing short circuiting, right? And so they know this. So when I run this code, it's not going to call compute. And look at the output. It's at path 2. And what is that called? Efficiency, isn't it? It didn't waste its effort. But then I take this code right here and I say temp. And I go here and say temp is equal to compute. Question for you. Will compute be called now? You said yes. Let me change the question. Should compute be called now? No. Why not? Because it's useless. But what does the compiler say? I'm going to call compute. How sad, isn't it? It did call it. Why did it call it? Because the compiler says, what if there was a side effect? You're like, hey compiler, what do you mean, what if there's a side effect? Yeah, what if the compute was doing something? And you tell the compiler, but a minute ago, you didn't call it. I'll tell you one thing you should remember forever. Never argue with the compiler, right? The compiler is always right. And if you ask them, they will say, it's called language spec. What does it's called language spec mean? Don't argue. That's all it means. We will not call it in the case of short circuit, other places we will. And you're like, okay, if that is the case, I really don't want you to call it. Well, then tell me it's okay not to call it. So notice what just happened. You just marked it lazy. And when you mark it lazy, the compiler says, oh, I won't call it until I need it. Just to illustrate the point, if x were 14, it calls the compute method. But if x were 4, it does not call the compute method. And so you can mark objects as lazy and say, defer the evaluation of it. And I won't run this until I actually need it. You have a similar idea in Kotlin as well. And you can make your code really effective, and you can reuse the code variables nicely without having to duplicate it. This is especially true when you want to use the temp multiple times in your code. You're not going to be reevaluating. It runs once and caches the result and reuses that. So that becomes very effective. Well, you can use beautiful pattern matching syntax in languages like Scala and Kotlin. I think I showed this in one of my talks earlier today. So I'll do this in Scala instead of Kotlin because I didn't show you in Scala today. I already showed you in Kotlin. So I'll show you in Scala. So I can write a function called process. Process takes an input any. And what can I do here? I'm going to simply print call for a minute. We'll come back to this in a second. So I'm going to call process over here. A process with what? A 1. I can call process with, let's say, hi. Let's start with that first. So what can I do in this code? I can say input match case, and I can say if it's a 1, I want to print out 1 like that. So when I run this code, what does it tell me? It says it's 1. I'll remove this for a second and run the code. You can see it says 1. Or what I can do is I can also say case x string, and I can say print line over here got a string. So when I run this code, it says 1, but if I send a hi, it says you got a string. That's a pretty nice way to deal with it, isn't it? But I know this is a little bit scary, but I can say process, and I can now say greet. Hello, greet. That I know makes you nervous, isn't it? In Scala, XML is a first-class citizen. So you can take this XML and you can just send it to this code. And how do I extract the data? No, you don't have to go for an XML parser. You can simply say greet message. And you can simply say here, got an XML. Or with message. Where, what is message? You can extract it with hello. Very powerful, isn't it? So if you can, yes, please. A little louder, please. Did you say regular expression? But people die writing regular expression. Here you can survive, isn't it? That's the only difference. Do you write regular expression often? Wait, answer this. Do you write regular expression often? No or yes? Yes. Do you have friends? I don't think so, right? Nobody survives writing regular expressions. And after you write it, I'll tell you why you don't have friends. Because nobody understands what you wrote. And they come and ask you, what does it do? You're like, it works. This is a lot cleaner, isn't it? I mean, don't get me wrong, regular expression is awesome. But you don't really do that too often because it becomes very hard. And how do you write this in regular expression? I'm going to ask you to write that. I'll give you 5 minutes. Can you do it? I'm not putting you on the spot. I cannot do it either. Oh yeah, even simple things are hard in regular expression, right? The only reason you use regular expression is to impress your friends. right? For no other good reason. I mean, sure, there is values to it, don't get me wrong. But you know what is really funny about regular expression? It's not regular at all, right? In a funny field we live in. We give these kinds of names to things. Yeah, okay. Auto casting in Kotlin. This is pretty nice feature. When you are writing code in Kotlin, you can do beautiful casting without having to do a lot of work. Let's look at an example of this. Suppose I write a function. Let's say this is Kotlin I want to write. So if I write a function, process, that takes an input which is input, let's call it any. And then of course in this case, what do I want to do? I can say when input. And this is a pattern matching in Kotlin. You can say if it is a 1, what do you want to do? Print 1. Let's start with this. So I'm going to simply call process here in this call and pass a 1 to it. And you can see that it's able to identify it's a 1 and print it. But on the other hand, if I say process and I say, hello, but then what do I want to do? I want to say this is a string. And what do I want to do in this case? I'm going to say got a string. So when I run this code, it tells me I got a string. But I want to know what the length of the string is. What do you do in Java when you have this situation? If this Java code, what will you do? You will receive public static void, some function foo. You'll say object input. And then what do you do here? You do something like if input is an instance of, right? Instance of a string. Then what do you do after the instance of? So you say if it is an instance of string, then you say, for example, length is equal to, can you say input.length? No. What does Java say? Java says, you better do this. Isn't that beautiful? What is this called? It's called punishment, right? Because you had to do it twice. Check once and do it again. But why? We can go directly here and say, hey, this is input.length. This is called auto casting. Auto casting, smart casting will do this for you automatically. But of course, you know it is a string when you get into this part. So if you go up here and say input.length, the compiler will yell at you. Say, what are you doing right here, right? Doesn't allow you to do that. But on the other hand though, down here, you don't have to cast it because it performs a smart cast automatically for you. Life becomes easy. I like that, thank you. So, how many of you have written code that has to write XML output? The hands kind of slowly go up, right? Because you never want a recruiter to be watching, he found one who can write XML, right? You're like, no. Okay, those of you who raised the hand that you have written code to do XML, how many of you, keep your hand up if you want to go do more of that tonight? No, right? Nobody wants to do that. Why? Because the first time you write code to write XML, you're like, this is interesting. Remember the word interesting? And then what do? And then you realize the code to generate XML should be given to people in the prison. Nobody in the free world should be asked to do it, right? Nobody likes it. But what if it is so easy to write XML? What would happen? Would that? Brendan Ike. And of course, just one more we'll throw in. Let's say C++. And that's, of course, Stewstrip. All right, so I want to print this in an XML format. How do I do this to print it in XML format? Just at this point. Then I say builder.languages. That's all I did, isn't it? When you run this, notice a beautiful little XML baby that just popped out, right? It says languages. Isn't that cute? Small little baby XML. But this is hierarchical. What is this called? A DSL, domain specific language, to create XML. You go into this layer and say language. And notice that baby now has a baby. Right? That's a child element within that. Now what can I do? I can now say langs.each. And what am I going to do here? Give me a key and a value, please. And I'm going to print that out for each one of them. We have 4 languages we printed out. And then of course, what do I want to do here? I want to say I have an author Well, maybe a language, right? So we'll say name. What is the name of this language? Key. So you can see it says language name is Ruby. Hey, what's the value of this? Oh, the value is going to be author. And what do I want to do for the value of this particular author? Let's kind of indent this properly here. So what do I want to do for this particular author? Well, maybe what I want to do for this author, let me try to get this indented here. So what do I want to do for this author of this object? Well, maybe for this author, I want to output the value of it. Isn't that nice? The only thing you have to remember is, tell the boss this takes 2 weeks to do. Right? And then just take the rest of the time off. Just don't tell them. And if they call you, you say, I'm working really hard, don't bother me, right? And this is as easy as to write it. So you can have a generator generate a DSL very nicely. You don't have to work so hard. Can you imagine writing Java code and then branching off and calling this really quickly? You don't have to struggle so hard. Life becomes really easy, right? So that becomes very easy to do. And this is what happens, folks. When you write beautiful code, people take photo of it. Right? That's how the evidence that you like the code, right? They say, wait, I'll take a photo. Of course, I also take photo of horrible code too, so never mind. Okay, that becomes a good example. You can do tail call optimization as well. I'll just mention this here without going any further into it. So what is tail call optimization? If you're going to perform a recursion is really cool, isn't it? What's really awesome about recursion? Recursions are cool because you can solve a problem using a solution to a sub-problem. Recursions have this little advantage, right? You write the code and you just look at it and you admire it and say, this is awesome. And then you call your friends and you have a recursion party that night, right? And you celebrate writing recursive code. This is beautiful, right? But then, you know how there's always this one person who spoils all the party? And what does that person say? Really? Recursion is cool, huh? It's like, look at this, it's awesome. And they say, try an input of 10,000. And what happens? The party is over, right? Because, yeah, it blows up with a Stack Overflow exception. And all your friends leave. And you sit there looking at the code, damn it, this is not working. And that's exactly where tail call comes in. So what does a tail call do? Tail call says, I will convert your recursion quietly behind the scene into an iteration. It'll rewrite your recursion into a loop. So you get the best of both worlds. Your code is recursive, but you can try with large values. It will never have a Stack Overflow. But for this, of course, you got to write your code in the tail call position, and only then will it work. And tail call position means the last call is a call to the recursion itself. If you're curious about it, look for tail rec, and that becomes really easy. But Kotlin is a language which has something called, it is called an extension method. So what is an extension method? What does it really do? Let's look at an example. So I'm going to say greet is equal to hello. And I'm going to print out greet right there. And what does it do? This is going to be Kotlin code, so let's go to Kotlin, so pardon me. So let's go to Kotlin code and try this and run the code. What does it say? It says greet, and it says hello. Now, imagine you see your best friend after a long time. Will you tell your friend, hello? Is that what you will do? No. What will you do when you see your friend after a very long time? You're going to say greet dot shout. That's what you're going to do, isn't it? You will shout and hello. That's what you're going to do, right? So I'm going to run this code, and what does Kotlin say? It says unresolved reference shout. How sad. Anybody thinks there should be a shout method? No? Come on. Do you guys have really friends that you meet after? Yeah, thank you. At least one person says that there should be a shout method, right? There's got to be a shout method. Otherwise, how do you express your love and affection for your friend, right? I mean, when I meet Raju, I don't quietly say hello. We create a chaos in the place. We shout, we run each other, we hug, and everybody's like, let's vacate the place, right? That's how they feel about it. And that's what you do. You celebrate. You just don't say hello. So if you think shout should be a method, what do? You go and say fun, string dot shout, and you implement the method. And what are we going to do with the shout method? You say equal to, and I'm going to say to uppercase. Right? You write uppercase. So what happens when you run the code this time? It is going to tell you, hello, and it shouts. I know what you're thinking. You're thinking, wait, let me get this straight from you. What is this greet again? Oh, the greet. Just to confirm, greet.foo. What does it say greet is? Greet is, well, let's try it this way. Greet equal to 1. Look at the error. It says greet is a string, isn't it? And you're asking the question, did you just do this? Did you take the sacred java.lang.string and add a method to it? How can you do that? Well, the last time I checked, we live in a free country. We can do anything we want with our code, isn't it? And now we just added a method called shout. Kotlin is filled with this. They have extension methods everywhere in the code. But you know what happened? I was giving this talk a few months ago, and there was one guy, kind of like sitting where you are. But the minute I showed this to this guy, he was like unbelievably excited. He interrupted me and said, hey, excuse me, Venkat. I said, yes. He said, I've got an idea for you. Can you do this, he said. I'm like, what do you want to do? And he said, do this for me. And he said, to lowercase is equal to uppercase, he said. And then you come here and say to lowercase, right? And when you run the code, the uppercase H. What scared me the most is not that you can do this in Kotlin, is how happy he was when he found out you can do this. And I had to ask, who else works with him? And everybody's like, not anymore, right? Dangerous code like this. So obviously don't do this, right? That's not the intention. And then finally I will say, Kotlin gives you beautiful fluency. Like what? I'll just give you one example of fluency to say how this would look like. Oh, yes, sir. Yes, go ahead. I love it. Thanks for asking the question. Nice question. So the question is, how are extension methods implemented in Kotlin? And that's a beautiful question. So unlike language like Groovy, which messes with your bytecode, right? And that's got power to it, no doubt about it. But Kotlin writes all your extension methods as static methods. So it's purely a compiler time thing. So they rewrite your code as a call to a static method. And the object on which you call the method becomes the first argument. And then everything else becomes other arguments. So it's very safe in that regard. It's just a static method. That's what they do under the hood. Good question. Thanks for asking that. So go ahead. Yep. No, absolutely. Pleasure to be interrupted. Go ahead. So what he's saying is, you spent an hour showing useful features. I have no question about it. But you showed me a feature where I can do tricky things now. I'm curious, bring it more, right? This is awesome. As long as you have an import to it. So essentially that static method, Kotlin has what are called top-level functions. A top-level function is a function that belongs to a package. You know, in Java we don't have this concept. Functions methods belong to classes or interfaces. Whereas in Kotlin, your functions can belong to classes, belong to interfaces, but they can be package-level functions. As long as you import that package, you can use that extension function. And that's what you typically do in Kotlin. You would import a particular package from the Kotlin standard library, and then you start using those extension functions. That's what you can do. Yeah, pretty nice feature, isn't it? So with that said, I'll show you one more example here. I'm going to say class pizza, and what am I going to do with the pizza? I'm going to define a function called, let's call it as, spread. And what I'm going to spread? Some topping. And I want to spread that topping, so I'm going to simply say over here, print line called. That's enough for our purpose. So I'm going to say pizza is equal to new pizza. We create a pizza. Pizza.spread. Let's go ahead and spread some cheese on it. And I'm going to say pizza.spread, and let's go ahead and spread some olives on it, right? Put toppings of olives on it. So I can run the code, and it's going to simply say called. It's telling me toppings is not being used. Don't worry about the warning for now. But that's okay, but that's a little noisy, isn't it? Wouldn't it be nice to write a nice fluent code? But did you notice there's a fluency already? What did we not use in this code? Semicolons, isn't it? That's the beauty of it. You don't have to use semicolons. But there's one problem though. When you write code in language like Kotlin, and then you go back and write code in Java, and you write code and you don't put semicolon. Why? Because by the time you finish writing code in Kotlin, you don't put semicolons. Your pinky is like so happy, right? You're not abusing me clicking on that semicolon. And then you compile your Java code, and the Java code says, error. And you're staring at the code. What's the problem with this code? It says you're missing a semicolon. And you're like, I'm not really missing it, you see, right? That's how you feel about it, isn't it? So the point really is, that's already nice. But wouldn't it be nice if we can do this? Give a space, and give a space, and give us. Wouldn't that be nice? But that doesn't work. So what can we do to make this work? You can go back over here and say infix. And this is a way for you to write an infix notation. Notice it says called and called. So you can write your code without semicolons, or without dot, and without parentheses. This leads to ability to create very fluent code leading up to DSLs. And you can create beautiful DSLs in language like Kotlin. And this is a statically typed language which you can create DSLs. And you get a compile time verification of your DSL as well. And that's pretty powerful, isn't it? So that is an example of how you can create a fluent syntax. So 12 different cool things you can do in JVM languages. If you want to download some of these examples, point your camera at the URL and download that. Hope that was useful. Thanks for coming.